Welcome, everybody. Greetings from Sydney, Australia. My name is Matt Ray. I'm Chef's Customer Architect and Regional Manager for Asia Pacific Japan. It's my pleasure to be presenting at the ChefConf sessions today. I'm actually calling from the future, so it's my morning. I'll be drinking my coffee as we talk. But what I'm going to be talking about today is Chef's tools and Terraform, how they work together, how they complement each other. And given this is meant to be an interactive forum, feel free to ask me questions throughout the session. It's less formal than regular ChefConf. I feel maybe a little more like a meetup. So I don't know where I'll see questions, but ask them. So first off, I'm here to tell you that the folks at Chef are very big fans of Terraform. We are, well, actually, we're fans of all of HashiCorp's tools, but today I'm just going to be talking about Terraform. So you're probably asking, that's great and all, but why are the folks at Chef such big fans of Terraform? Well, first off, we're heavy users of it across our organization. Our development team uses it quite a bit. Our product uses it. We embed it in some of our professional services offerings. We use Terraform to deploy some of our multi-node HA clusters for both our customers and for ourselves. We run a few hosted services, and almost all of them are managed by Terraform as well. Our development team uses it as we test different topologies and different configurations of our applications, and definitely our customers use it quite a bit. And so we see provisioning and configuring of infrastructure as essential to how Chef manages servers with configuration management. Not only that, but our customers and our users use it, and there's extensive integrations across Chef's projects and Terraform's and lots of other HashiCorp projects as well. And I see I wrote example 3 there. There are lots of complementary use cases, and our companies have been known to do webinars and other events together. So hopefully, I'm sure this isn't the only session that'll talk about Terraform. So hopefully, those of you here at ChefConf sessions, ChefConf Online, you already know what Chef is. But for those of you who might be tuning in from the HashiCorp side of things or the Terraform world, Chef, we're an open source automation company. Our mission is to help the most enduring and transformative companies use Chef to become fast, efficient, and innovative software-driven organizations, and Terraform's part of that. So when I say Chef, from here on out, I'm probably going to be talking about Chef Infra, which is what we call the software. So there's less confusion. And so Chef Infra is our open source infrastructure automation to provision, harden, and maintain the configuration of your servers, laptops, desktops, whatever, no matter where they are. So those of you who don't know what Terraform is welcome. So what Terraform is it's a powerful and flexible tool for provisioning and managing infrastructure. Terraform is not configuration management, so there's a slightly different take on that, but Terraform is everything above the server, or below, depending on how you like to think about it. But when it comes to standing up your virtual or cloud infrastructure, even physical in some cases, Terraform is the stuff that stands up your VPCs, your load balancers, provisions, access to databases, security groups, things that traditionally are outside of Chef's purview, and so that's what Terraform does. And when it gets to actually provisioning the server, Terraform lets you use any configuration management tool to set up that box once it's been instantiated. And so I'll be talking about Chef and Habitat in that case. And Terraform has many providers. It's open source. Lots of options out there. So speaking of lots of options, there are a lot of tools out there. There's, in this photo, we've got lots of different saws and hammers and knives, and everybody has opinions about which is the best. And so what we want to do is kind of focus on what Chef what Chef's tooling brings to this conversation with regards to Terraform, and how we can put the best tools together and just as few solutions as possible to get to that elite performance destination. You know, a stack that all fits together and makes coherent sense. That's kind of what we all want. So we can focus on your goals. And so what we do here at Chef is we focus on three primary areas. Most folks are familiar with our infrastructure as code offering, the Chef Infra part. But if you're managing infrastructure or anything really, you're going to want to run it securely in a compliant fashion, of course. So our security compliance code project is called Chef InSpec. And we figure that managing applications isn't the same as managing servers. So we developed the Chef Habitat platform to help manage the life cycle of your applications no matter where they run. And so I'll be relating Terraform back to each of these. But obviously, hopefully, hopefully those of you here at ChefConf are familiar with the benefits of having your stack defined as code, right? It allows you to manage different versions of it, track the evolution of it over time. Testing, of course, is important. You know, the folks here at Chef, we're all big fans of testing. And you know, code is fairly unambiguous. It does what's expected, and it allows you to establish that software lifecycle for the entire stack. You know, from the provisioning of the infrastructure to the servers, to the applications, and the compliance across everything. So, you know, hopefully everyone here is already familiar with Chef Infra. So it's you know, it's configuration management, Linux, Windows, Unix is whatever operating system you have, VMs, cloud, bare metal. You know, you've probably seen versions of this slide over the years. Now it's available in YAML, but we'll go ahead and skip ahead. So if you read through the Terraform provisioning documentation, you'll notice that the HashiCorp folks have fairly strong opinions against using provisioners. The goal, of course, is to have your immutable infrastructure, right? You want to have a machine that you just stand up and it runs your application, and you never think about, you know, changing it over time. And so every single provisioner page in HashiCorp's documentation kind of recommends against using provisioners. The idea is that you're going to use probably Packer, you know, to build yourself a golden AMI that just boots up and runs your application and doesn't need any configuration after the fact. Cloud Init, another popular option with a similar approach. But unfortunately, not everyone builds their images in advance. Perhaps you've got too many variables in your applications, your infrastructure. Some of those machines may be long-lived, right? And they're, you know, you may be expecting to deploy into dynamic environments that, you know, they can't be configured easily through Packer or Cloud Init, and are going to require some post-provisioning configuration. So that's where the provisioners come in. And so the first integration I'm going to be talking about is the Chef provisioner. So if you want your resource, your cloud instance, for example, to be managed with Chef, you'll use the Terraform Chef provisioner. Their documentation is very thorough. There are a whole lot of users using the Chef provisioner already. It focuses on managing your nodes in conjunction with the Chef Infra server, right? Not everyone uses that. So if you prefer to use Chef Solo, Chef Zero, you could easily use the local exec or remote exec provisioner to kick off a script. Their documentation doesn't cover that example, but if you take apart the install sh script or write your own bootstrap template, it's fairly straightforward to use that mode. Of course, the downside is you don't have a Chef server to distribute your artifacts, you know, your cookbooks, your policy files, what have you, and you don't get search and data bags. But you know, there are use cases for all those things. The Chef Provisioner does support all the different Bootstrap options that are listed in our documentation. So, you know, specifying which version of the Chef Infra client, passing secrets, proxies, you know, what pretty much everything that Knife Bootstrap supports is going to be available through the Chef Provisioner. Um, and part of that provisioning is you're going to assign run lists to your node, whether you are still using roles and environments. Um, if you're using policy files, that's what my demo will be using. That's how that's sorry. If you've got policy files, that it's going to support that. Documentation, very thorough. So again, that's the Chef Provisioner. And so I've got an example of using that. This is the snippet of code from a demo I put together. It's up on GitHub. I took the simple AWS provider two-tier example, forked it a little bit. Instead of using a bash script to provision it, I used the Chef agent. I've got a little simple Apache cookbook that stands up a web page. But the Chef provisioner part is fairly straightforward. We've got the client options to accept the license, to recreate the client if we're standing up the same machine again. Obviously, the server URL, user key, username, you'll store those in your Terraform TF vars. That is not on GitHub, but the variables TF is there. I'm using a policy file, and I've got the node name is there, and the policy group and policy name. And so that goes into our demo. So first demo we have here. Let's see, I'm using Terraform version 12.24 with the AWS provider. I'm calling Terraform apply. This is fairly straightforward. It's not a big environment, so you can see here I'm using the Chef provisioner. So we see the AWS instance provisioning with Chef. Now this is pre-recorded, so it shouldn't fail on me. We're using the 16.0.275 client that was released a day or two ago. The name of the box is ChefConf 2020 demo. And there are the licenses for Chef Infra and Chef InSpec being accepted, and the policy file that was attached to it. And after a minute and 16 seconds, it's done, and spits out a load balancer address. I go to that, and there is my simple web page. Fairly basic stuff, but we're gonna revisit this as we go through the session. So that's what a provisioner does. Now, a provider is slightly different. So within Terraform, providers expose resources on external systems for management by Terraform. This can be AWS, Azure, GCP, but also like web services like Auth0 or PagerDuty. In this case, we're talking about the Chef provider. What the Chef provider does is it exposes resources on your Chef Infra server, lets you manage your environments, roles, data bags, nodes. It's been around for quite a while, but there are some gaps in the coverage. If you need to do things like manage cookbooks, policy files, access controls, those are missing, but probably the use case for most folks using the provider are going to be things like in your CI/CD, provisioning data bags, or maybe you're using roles and environments still. You should upgrade to policy files, but you probably use it in like a CI/CD environment to make sure that everything is properly provisioned. The documentation, there's the URL for it. The code is up on GitHub if you want to add those missing features, but it mostly works. And here's an example of some of what that code looks like, where you just specify the provider, the URL of the server that you're going to connect to, and then the sorts of resources that you're adding. In my example here, I'm creating a data bag, adding an item to it. I'm going to add a role and an environment, and so let's just go ahead and watch that quick little demo here. My environments, all I have is my default. My role list is empty, and so now I'm going to go ahead and Terraform apply. I'm using parallelism 1. data bag item creation can be finicky because it needs to take a breath for that data bag to be created on the Chef server. It needs more retry logic. Um, so that's why the parallelism equals 1 is there. And I can see I've got my environment, my ChefConf demo environment, my CC role has been uploaded to the Chef server. My data bag item of example item has been added to the example data bag. And so if I call Terraform destroy, it goes to the Chef server, deletes those things. If I say environment list, it's gone. If I say role list, it's gone. Um, it's fairly basic, but I imagine it as code, and that's what we want here. Um, so next up, oh, don't want to watch the demo twice. All right, so Chef Habitat. There's going to be a lot of Habitat content for this ChefConf session, so I'll probably touch on this fairly lightly. But Habitat is our application automation. It manages the application life cycle, going from building the application to deploying it to managing as it runs. It's different from Chef, but the key here is we're putting immutable build artifacts onto machines through release channels and getting a consistent behavior of our applications on those platforms. So Terraform is going to stand up our infrastructure using whether it's AWS or Azure, VMware, wherever it may be, and the Chef Habitat Provisioner is going to install the Habitat agent on that machine, or the Habitat supervisor. It's going to configure that supervisor, whether it's setting up peers and rings for it, how it, what channels it's subscribed to, and then it's actually going to configure the services on that supervisor and the topologies and their upgrade strategies for the applications that you're going to be managing with Habitat. As well as handling the binding to other applications. Documentation is there. It's currently Linux only. I know there's a lot of work being done on the Windows side of things, so maybe by ChefConf it'll be supporting Windows, but right now it's Linux only. But it's going to put the Habitat supervisor and your applications on whatever machine you've just provisioned. There's an example in the Terraform documentation of standing up an AWS instance and then putting three Redis machines on that box. I'm not going to run a demo of this today, just in the interest of time. But you can see there that we're standing up our Habitat service. It's going to be running under systemd, and we're going to take the core Redis package with a leader follower topology and a TOML file for configuration. So you could manage that TOML file through Terraform as well, passing in whatever variables you may need. Fairly straightforward. So InSpec, our Chef InSpec, is our compliance and security as code project. Again, this being ChefConf online, hopefully you're already familiar with it. But the reason I bring it up is there are a couple of different integrations with Terraform. The first integration is Kitchen-Terraform, and this integration is a little different. Hopefully you're familiar with Test Kitchen. What Test Kitchen is, it's a testing framework that allows you to have different provisioners for what you're standing up, whether it's AWS or EC2. In this case, the Terraform is the provisioner. So what this does is, under the covers, it's going to call Terraform apply to whatever Terraform TF files you have, and stand up that infrastructure. A really handy use case for this is if you need to do cluster testing. If you have multiple nodes in your application and you've been wondering, how can I get multi-node testing with Kitchen? This is one tactic that a couple folks have used. This is provided by the folks at New Context. It's up on their GitHub. It's open source, of course. But what it after you have stood up your infrastructure with Terraform Apply, you can use InSpec as your verifier. And so this allows you to test your Terraform code that's behaving as you would expect, right? We want to make some changes to how our cluster gets deployed, and we have InSpec profiles that check, that the applications running on it are configured properly, we're getting the right responses, the machines are as secure as expected. All that can be done with Kitchen-Terraform. You don't have to use Chef. You can use Bash or Puppet if you want. But the real key here is we're using InSpec to test what Terraform is standing up. Annie Hedgepeth gave a really great talk at HashiTalks 2020 earlier this year. So I'm going to defer giving a demo and recommend that you go watch that talk, because it's about 30 minutes on this content, and she covers it really well. So hopefully you have a chance to look at that. And so InSpec supports a lot of different cloud providers. And the Center for Internet Security certified the InSpec integrations with the various AWS, Azure, and GCP clouds. We were the first partner certified on all those platforms. And what this means is we have really good coverage of the compliance of your infrastructure on those clouds. What we're not just talking about, the Windows running on GCP, but actually, how your security groups are set up, your VPCs, load balancers, elastic file systems. A lot of different cloud resources are exposed to these, and this allows us to check the holistic security of your infrastructure. You can use InSpec to write upfront profiles. You're looking for how your identity and access management is configured. With Chef Automate, we're shipping the Center for Internet Security benchmarks for the clouds. So you can make sure that how you're standing up your infrastructure is up to at least their expectations. And the reason having all these resources available to us is useful is there's a Chef InSpec plugin called InSpec Iggy, that Iggy stands for InSpec Generate, that allows you to generate compliance controls from your Terraform. It's going to map the Terraform resources to InSpec resources and export those as a profile. And so what this allows is for dynamic generation of your InSpec coverage of whatever you just created with Terraform. And so just a caveat, I'm the author of this, so if it doesn't work, it's my fault. But I'll be demoing that here in a second. And they're kind of two main ways of using the Terraform coverage. InSpec Terraform Generate is going to take your TF state file and map all those resources to their InSpec equivalents. So if in the case of our demo, we've got a VPC, security groups, elastic load balancer, and a web instance. It's going to create a coverage of that. And then there's InSpec Terraform Negative. What Terraform Negative does is you pass the TF state file, and it's going to find everything in your VPC that is not managed by Terraform. And this is useful in the case where everything in your infrastructure is managed from Terraform, and you want to find anything that has drifted or been added to your VPC. So maybe you've got 100 nodes running in your VPC, and InSpec Terraform Negative might say, actually you've got 105, and you've got 5 triple XLs running some sort of Bitcoin mining. So it's a way to detect drift and find things that are not managed as code. And that's really the goal here, is to keep everything managed by code. And so it's up on GitHub. It supports AWS, GCP, and the Azure development is under development. It actually also supports CloudFormation. So, I know I'm here to talk about Terraform today, but it does support CloudFormation, and I've been asked to add Azure ARM templates. So those will be coming in a release soon. As far as your TF state file, you can obviously use a local file, but it also works with S3 and HTTPS backends. So it doesn't work with everything yet, but it is open source. So there you go. So let me give you a demo of what that looks like and how you would use it. So I'm using the new version of InSpec, 4.18.111. InSpec Iggy, I'm using a development version. This will be up on GitHub by ChefConf, I promise. And it's I'm going to run InSpec Terraform generate against my TF state, and it's going to pop out a compliance profile. My InSpec YAML is automatically generated. All these fields can be passed as CLI options, so I could have maintainer and copyright email license all provided. And I'm depending on the AWS resources. Those were broken out of InSpec, and so you have to load those. And here is the code that it generates. We've got our Elastic Load Balancer. It's got a name, ChefConf VLB. It's in the Southeast, the Sydney availability zone. It's got a DNS name that was dynamically generated. We've got our AWS instance with its ID. It's again running here in Sydney on a subnet. I've got security groups, subnets. All that stuff is dynamically populated, and you just kind of get this for free. And our VPC, obviously, it should exist, but you've got our owner ID and the VPC ID. So if any of this changes, we're going to detect that. So I run inspec exec ChefConf profile against that. Against the AWS, and ta-da! It runs inspec against my cloud resources and reports that all this stuff that you just generated is there. Terraform built it, and inspec validates that it's there as expected according to your TF state. I've got 6 controls for free, 25 tests off my fairly simple demo. Now, if you attach an inspec JSON to it with a UUID, a token, and the URL, you can actually send this to Automate. And so let me show you what that looks like. Over here in Automate, I just ran that. I click on nodes, and I can see my ChefConf Iggy, and here is my output, right? The stuff that I just created is now showing up in Automate. I could have it run this every 30 minutes. There's our source. It's fairly straightforward. But let's do something interesting with that now. Okay, so I've got my Terraform TF state file here, and I'm going to go ahead and just destroy that box, or that box, that infrastructure. So as that kicks off, well, I got to give it a second to actually destroy. Let me destroy it again. So there we see stuff has started to get destroyed, and I'm now going to run inspec against what I just destroyed, and it's going to complain that some of that stuff can't be found. And so if I come back to automate, now I've got red on my dashboard, ChefConf Iggy's turned red. The ELB was already down by the time I ran this. I'm getting failures. And so, this is what we expect. So if we're monitoring our infrastructure over time, we can see as changes are happening. So if something was expected to be there and now it's gone, we're going to catch that. So hopefully, if you've got your notifications integrated, or Slack or what have you, you're going to get notified when your infrastructure has disappeared or changed, and that's the reason we use this for drift detection. All right, so that's just kind of a quick overview of the different integrations that are available. All the different chef tools have some touch point with Terraform. Hopefully you've gotten a little something out of that today. Because Terraform is quite a popular tool for infrastructure provisioning. again, it's all up on GitHub. My demo and all the commands I ran, those are all available as well. So if you have any questions about how this works, that's all up there. Yeah, so that's me. URL to the repository on GitHub. You can drop me an email if you want. I'm also, of course, on all the Slacks and Twitter and GitHub, and I have a podcast called Software Defined Talk, and a blog, of course, where I post mostly tech stuff, mostly related to Chef. And yeah, thanks for having me. Any questions?
Awesome. That was great, Matt. So do you taking pull requests and other external contributions on Iggy and your other projects?
I absolutely am. There are a number of customers using Iggy in production, and so definitely definitely taking pull requests. I've had a couple folks send me some useful things. Also, I had I gave a similar demo at HashiTalks, and someone sent me a pull request for Singapore support. So if you'd like to run my demo in a different environment, happy to take pull requests. So yeah. I just put it all up on GitHub. Again, I'm in Slack. I am in Sydney, so my time zones are probably off of whatever yours are. But happy to help you out if you have questions on any of these. I mentioned some of the features that might not be fully fleshed out yet on some of these integrations. There's not enough hours in the day to fix everything, but if you run into them, I could probably help you work around some of them. But yeah, Chef uses a lot of Terraform, so hopefully we can help you out.
Awesome. Any other questions? I don't see anything in the Q&A yet, but we have plenty of time if folks have things they'd like to ask Matt about Terraform or InSpec or whatever else is on your mind. There we go. So here's one. Any good open source examples of Chef using Terraform for its products and testing? All of our tests are out there, aren't they?
Yeah. So I know the Chef server testing is done with Terraform. Because we roll out a couple of different topologies of that. I don't have the URL off the top of my head.
I'll see if I can find it.
Yeah. We do have a professional services offering around our managed HA clusters. I don't think that's in a public repo, but some of the testing of that maybe. Yeah. Trying to think where else we would have stuff publicly accessible. We had our demo environment that we've since deprecated called BJC. That was the Blue Jeans company, if you ever got to use that one. That was the Chef Infra, Chef InSpec demo, detect, correct, and automate, where we stood up about a dozen machines, including automate and Chef server and workstations. That was actually done with CloudFormation. But if you go through the Iggy in my test, Iggy's got a lot of tests, and so the test, the JSON for that CloudFormation is in there, as well as some of the later Terraform demos are in the test suites of Iggy. So I kind of dog food a lot of our demo environments for testing. Iggy does use InSpec to test that InSpec is working properly. So that's an interesting use case in the tests of Iggy. So if you're looking to replace your RSpec with integration tests, there's an example for you there.
Cool. And I did post a bit about a link to our Terraform setup from the Chef server repository. Some of it's pretty specific to our stuff because we use like Okta for auth and some other things, but there's at least some stuff there that you can take a look at to see if that's helpful for folks.
Yeah, and in
oh, go ahead.
I was going to say, in some of the Chef CFT repositories, I think there are a bunch of Terraform examples in there.
Yeah, let me see if I find. They're not under our chef org, are they?
We have, Chef has about a dozen orgs,
No.
chef-CFT.
Oh, there it is. Okay, I'll see if I can find anything in there. Another question. This is an unfortunate one. Where can I find a development roadmap for Test Kitchen? I don't know how much you want to get into the life of Test Kitchen, but
Yeah, I'm not the guy. Yeah, I'm not familiar with that. I know, we'll I know that they are releasing some updates for Test Kitchen around, obviously for Chef 16 support. There's, as of this recording, I haven't checked Slack. They're about to roll out a new Chef Workstation release that probably has a refresh of Test Kitchen. Hopefully there'll be a Chef DK4 release slightly after that. Um, I don't know the roadmap for Test Kitchen, sorry.
yeah, and I'm not sure that I have heard anything recently either. But if you would like to know more or would like to sort of join that project, there are channels in our community Slack and lots of folks that are invested in that project and working on it over there. So community Slack is a good place for that sort of thing for Test Kitchen. Anything else people would like to know? How much fun was it to upgrade from Terraform 11 to Terraform 12?
It was actually surprisingly not that bad. Yeah, I maintained the Terraform 11 support for a long time, just like everyone else did.
Right?
um, and I kind of resisted upgrading because I didn't want to rewrite my existing Terraform. But when I finally did it, it probably took an hour or two, just because the format of the TF state changed a little bit, but at the end it was still just JSON. And half the programming I do is really just manipulating JSON. So it wasn't too bad to change. I have had people ask me to bring back Terraform 11 support.
Hmm.
Probably not going to do that. I mean, Iggy is a labor of love, I guess. It's something that I just kind of had this crazy idea that Terraform resources would map to InSpec resources one-to-one, and it, I was right for AWS. And then
Yeah.
everything after
Mhm.
that has been pain. Um, and so now Iggy has, I'd like to think that Iggy has extensive developer documentation because I wrote it, but the intention was like, if you wanted to add platform support for something else, you could walk through the developer docs. And what Iggy's turned into is all the other platforms have a lot more mapping of, and special conditions where things don't map up as easily as the AWS ones. And so, you know, the first incarnation of Iggy was really fast, and everything else has been a lot of JSON manipulation. But trying to think where I was going with that. Adding Terraform 11 support would not be that hard. I kind of, if you really want to add it, I would not turn down your pull request because Iggy has a lot of tests. And so, talk to me offline. You can hit me up there at ChefConf at mattray.dev or matt at chef.io if you prefer. And we can bring back Terraform 11 support, but honestly, I don't want to maintain it. But the test will let you maintain it, right? So if
Yeah. Cool. All right. Anything else, folks? We have some time. If there's nothing else, so we'll let you go. A couple quick notes. Matt mentioned Annie's talk from Hashi Talks as well. She is going to be giving a version of that with ChefConf online. So if you are watching this recording in the platform later, please find that talk. And otherwise, for folks watching us live, we'll see you next week, hopefully at her talk, and you can ask her questions there too. So thank you, Matt. Thank you for all of our attendees, and we'll see you later.
Thanks a lot, everybody.